My name is Paul Massey. I'm the founder and director of Bluefruit Software. I founded Bluefruit Software back in 2000. I've been running 15 years. We've got 30 staff now, 18 software engineers, 5 test engineers. We specialise in writing embedded software. So this is the kind of software that you get in electronic devices, from toasters to helicopters to medical equipment. We have customers in quite a broad range. Go on in. Bring out a check. We have customers in quite a wide range of sectors, from automotive, aerospace, scientific instrumentation, consumer goods. The thing all of our customers have in common is they really care about quality. And so as a business, over the years we've developed a really strong focus on quality, which is why I want to talk about it today. We've been Agile since 2009, so we've got 6 years experience under our belts now. And in terms of the flavour of Agile, we've been very strongly influenced by Mary and Tom's book, Lean Software Development. But we've had a lot of input from various coaches, many of them are here today. Seth Rose here, and John Jagger's here somewhere, and many others. So today, I'm talking about quality. Quality means lots of different things to different people, so I'm going to start by explaining what quality means to us. And then why quality is important, and finally how we've navigated that quality journey so far. So, what does quality mean? Well, we can start by looking at some quality products, see what success looks like. So there's a few examples here. Not everyone will agree, but generally there's some Apple products, Fitbit, Dyson. There's this water purifier here. That's there. It won the Red Dot Design Award, top quality product, and it's the one that we worked on. Have that there. So when we look at all these different products, we hear lots of different comments about them. Lots of different voices from lots of different perspectives about how they look, whether they're time saver, about build quality, and never go wrong, how intuitive they are, and so on. So there's lots of different perspectives on what quality means. But what we can do is we can start to categorise those into three main areas: how it feels, how it delivers, and how it's built. In fact, we can just boil that down a little bit further into the user experience and how it's built. Again, drawing on Mary and Tom's book, they describe these as perceived integrity and conceptual integrity. I'm going to talk a little bit more what they mean. But to us, these two concepts make up the true definition of quality. So starting with the user experience, we have this kind of pyramid of needs, a hierarchy of needs here in the software. So we start at the bottom with the functional. It needs to actually work. It needs to do what the customer wants it to do. It needs to do that reliably, and it needs to be easy for the customer to do that. So they don't need to put too much energy into achieving what they want to achieve. It's economical, and the usability is how easy it is to achieve that and how intuitive it is. And it's got to be meaningful, so it's got to deliver real value to the customer. And finally, it needs to be pleasurable. The further up this pyramid we manage to achieve, the more successful we've been in delivering a quality user experience. So these are all the things perceived by the end user. And then there's how it's built. So there's the scalability. This is how easy is it going to be to add features to it, do new generations of the product. The maintainability is particularly important in an agile environment. So it's really important that we can adapt and respond to emergent knowledge, the unknown unknowns that emerge during the project. We're going to need to rework our software and change direction, so it needs to be maintainable. And habitability kind of overarches these, so this is how easy it is to live and work within the environment of the source code. How readable is it? How easy is it to modify? How easy is it to understand? So that habitability feeds into those other two. So we summarise these two areas, the perceived integrity and the conceptual integrity, with our plant, our Bluefruit plant. What we're trying to convey here with this image is that there's a whole bunch of stuff under the ground that the end user can't see. This conceptual integrity, how well it's built. And it's really important that we invest a lot in this area, that we invest in those roots, that we nurture them, we water them, we cultivate them. And if we don't do that, then it's very difficult to achieve that perceived integrity, that stuff that the user can see above the ground. So that's what quality means to us. So we'll move on then to why that's important to us. Or why it's important to anybody. So everybody has their own business models, their own business goals, their own vision for their business. The vision for our business is we'd like to have 100% happy customers 100% of the time, 100% happy workforce 100% of the time. I'm sure he's got my back and 100% successful projects. That's our goal, that's our vision. And that's why quality is important to us. Because quality helps us deliver that vision. I'll talk a little bit more about that in a moment. Something that a lot of people may have heard is that quality comes for free. For us, quality doesn't just come for free, quality pays. Well, these are quite strong assertions. I'm going to just try and back those up a little bit with the rationale. So firstly about why quality pays. In my view, quality is a strategy, not a tactic. Firstly, could anyone just offer a kind of definition or explanation about the difference between strategy and tactics? Thoughts?
Long-term, short-term?
Timescale.
Long-term, timescale.
I think strategy is your overarching goal, and tactics are the means you'll use to get there.
Yeah, exactly. So the thing that's really important, I think what's really important to understand is that about strategy is it's about the long-term picture, but it's about making sure that all those day-to-day activities are all working together, are all pulling in the same direction. So if we take that back to the kind of quality description, then if we just view quality and quality activities as tactics, then they can seem expensive things to do, doing extra testing or pair programming or any of these activities. In the short term, they seem to take a bit longer to do the same activities if we didn't do them. But if we take the strategic view, then the value that we build within our business and the value that we build to our brand significantly pays back more than the cost of doing these activities. That feeds into how quality helps us deliver successful projects. So this is an old project management model called the Iron Triangle. A lot of people have probably come across it, where we're trying to balance within a project scope, so what features we've got in our software, the budget, and the schedule. When we look at projects, we like to introduce a fourth element to quality. It's a kind of hidden variable in this triangle. We think it's really useful to keep that as an extra variable to understand. So if we just explore this model, in a traditional waterfall type project with a fixed price contract with fixed scope, then what happens is written into the contract will be the scope, the features that we're trying to deliver, and there will be a budget written into there too. So if we start having problems in that project, then what happens if these unknown unknowns emerge, as we know they always do, then there will be pressure on that project. And often what happens is the first thing to give is actually quality. We look to see whether we can do a little bit less testing or whether there's maybe a bit less pair programming or something, just so we can try and get a bit more throughput. And then next, it will probably be the deadlines which start slipping. And if the deadline slipped by a long way, then the budgets might need to be renegotiated. Finally, last of all, under these contracts, you might start discussing about whether there's some features we can do without. There's been loads of studies which have shown things like 64% features are rarely or never used, and this is the rationale behind Agile. Actually, it's the scope is the first thing that we should be trying to flex here. So I think this model works well to explain how Agile helps. So with Agile, we fix the quality. We get very disciplined about the quality of every sprint that we work to. And then at the end of each sprint, we review the scope. And this gives us lots of control over the budget and the schedule. And we're making deliberate decisions about what features are in and when. So we call this our quality first principle. This is about making sure that we're 100% committed to never compromising on keeping quality at the top of this pyramid here and keeping that one fixed and making sure it's just the other ones that fail. We believe any other approach is basically a false economy. And this principle basically helps us deliver our vision. So just to summarise on the whys, you need to view quality as a strategy, not a tactic, and then you can understand how quality pays. And then being absolutely committed to this quality first principle ensures that we deliver successful projects, which leads to happy customers, which also leads to happy workforce, and the commitment to quality feeds strongly into the happy workforce as well. So that's about why we're so committed to quality. Finally, I just want to talk about how we deliver that quality. The short answer to this is the Agile Toolkit. Agile enables us to deliver quality. But one last model just to explore, which is looking at these three constituents and how they help us deliver quality and how they help us understand how we use our Agile Toolkit. So there's the customer, the engineering team, and the product itself. And then we use our Agile Toolkit to create feedback loops between these three entities. So the effectiveness of the interaction between these determine how successful we are at delivering a quality outcome. Let me explain what I mean. So first of all, we have an interaction between the customer and the product. This is the user experience. This is the goal. This is the focus of what we're trying to achieve. And then the engineering team work with the customer to capture their requirements so that we're meeting that user requirement, that achieving that user experience that we want. And then finally, the engineering team has to convey those requirements to the product through a programming language and a compiler and the tools that we use. Just to bring that back to our definitions of quality, that top half of stuff there is the perceived integrity, the stuff that can be seen above the surface. And this stuff under the ground, the conceptual integrity, is absolutely vital to achieving that strong quality user experience. So far, I've been talking for 15 minutes, and I've not mentioned bugs at all. Bugs are what quality means to a lot of companies. For us, they're about a symptom. We don't have to obsess about those bugs. We might use them as a metric to understand how successful we'll be, but they're not the core focus. But I'm just going to explore this model in the context of bugs. So, what is a bug? Well, bug is when the software doesn't do exactly what the customer expects it to do. So, this interaction between the customer and the product, something isn't quite as expected. Now, often this is put down to coding bugs or software bugs. So it's kind of blamed on the developers or the engineering team not successfully capturing what the user wanted into the product. And this happens sometimes, but often what we find is this other area, which is the requirements haven't been successfully captured. So just as a kind of trivial example, if you were inventing a toaster, then you might have captured requirements saying that you want to put the toast down, cook it for 3 minutes, pop up, and you have nicely browned toast. And the engineering team might perfectly develop that, but you get burnt toast at the end of it. And we would describe that as a requirements bug. Maybe it needed 2 minutes rather than 3 minutes in the toaster. And we find it really useful to differentiate between these different types of bugs, coding bugs and requirements bugs, because they help you understand and review your processes and where the weaknesses are and where you can get better. So how does Agile help with this? Well, the goal is this quality user experience at the top. And then the Agile Toolkit helps us in these other two areas. So first of all, we want to make sure we build the right thing. And there's a number of tools in the Agile Toolkit to help with this. User journey mapping, user stories. The one that we really focus on most, and I'll put at the top of the list, is behavioural driven development. Talk about that a little bit more shortly. And then secondly, we then want to make sure we build the thing right. And again, we've got lots of tools in our Agile Toolkit to help with this. The one, again, put top of the list is test-driven development. Quick show of hands, who's familiar with TDD, test-driven development? Most people. And who's familiar with BDD? There's a kind of Bluefruit bias in the room, I think. Okay, well, I've got one slide on those just to briefly describe what they are for the people who aren't familiar with them. So TDD is a way of delivering the software, doing the actual coding, and for this interaction that I was talking about between the engineering team and the product, to make sure that the engineering team are achieving what they want to do. I think in the keynote speaker he talked about it being like the, what's it called, the double accounting, double entry book you can do, yeah. And that's exactly what TDD does. So it's an iterative process where we take a task that we want to achieve, we write a failing test to tell us when we've completed that task. The test should be failing so that we know the test is valid. If we haven't seen it fail, then we can't be confident that the test means anything. We then write some code to pass that test. And then we have an opportunity to optimize our solution, make sure it's readable and habitable, and that's how TDD really helps in this interaction and driving the quality up. And BDD, technically, is a very similar practice, but philosophically it's got a very different goal. It's about the communication between the customer and the engineering team. But we go through a similar process that we capture the acceptance criteria in plain English, what we call our ubiquitous language, something that the customer understands, the developers understand, and the testers understand. And the development team then automate that test in a very similar way to TDD, and they iterate around the TDD on their tasks until the acceptance test is passing. And then we do the ordinary loop then of putting it in front of the customer and making sure that it all works as we expect. So just returning to our quality wheel, to recap on the how, so we focus on the goal of delivering a quality user experience, and we use BDD to make sure we build the right thing, and TDD to make sure we build the thing right. So just to summarise, overall, what is quality? Well, it's summarised with our plant here. So it's about all this perceived integrity, but what mustn't be forgotten is the energy that needs to be put in to make sure those roots are healthy. And we invest a lot of time and energy in making sure that we can do everything we can to make sure that project is habitable, maintainable, and scalable. Why do we do it? Well, it's for our vision, for our business, to ensure that we can keep quality first, and keeping quality first ensures that we have happy customers, happy workforce and successful projects. How do we deliver it? Well, we focus on these feedback loops between these three constituents. Thank you. That's my talk. Any questions?
How do you actually sort of measure quality through You say you deliver the quality product. One of those things is
Well, we don't have too much emphasis in terms of actual metrics, so we do it more sort of qualitatively. So we, in terms of our processes, we focus a lot on code reviewing and making sure, and peer reviewing, making sure the team are happy that the code is habitable. And we use Git. We use the pull requests on GitHub to make sure that the code is good before we accept it into the code base. And we speak to our customers, and that's an area we're building on, but we're looking to survey our customers on a more frequent basis to ensure that they're happy with their products. We work as a kind of contracting business, so we often have to work with our customers to understand how we can get contact with the end customer, because it's the end customer that we're really trying to get the user experience to be good. So we have to work on a project-by-project basis in terms of what's the most effective way of us getting that direct feedback.
So if you are working on embedded systems, does that mean that ultimately you only have one chance to get it right in terms of finally shipping a product to the end user? Say I wanted to buy a Dyson Hoover. Do you get to iterate on your work at all in that sense? Or?
Yeah, we do. I mean, it varies a lot from one project to another, so it's more and more common that the projects we're working on have in-field updates, so even for embedded products. So there are opportunities there, but where that's not possible, then we just need to make sure that there's sort of an extended sort of field trials type period where we can get feedback there and apply it.
Do you ever find yourself in a situation where you need to sell the benefits of conceptual quality and clients don't see it?
Yeah. I mean, we have customers. I think we've got some in the room today, actually.
Tell me later.
We have quite a broad range. So we have well-established customers who are very experienced, and they can very quickly relate to what we're talking about here. We also have customers who are maybe entrepreneurs or who have just got a new product, and we have to do a lot more in the way of educating. So we have quite a broad range. We don't actually train ourselves, but we just have a principle of kind of leading by example, showing how we do the work. So we have some customers where they have their own team and we collaborate with them. We have other customers where we are their entire software team. Where they have a software team, then we just lead by example, and they can see how we work and pick and choose what works for them. But where they don't have any software in-house, then we tend to need to do a bit more in the way of educating. Yeah?
So you mentioned when you're doing your BD, that's business-driven development, right? So
Behavioural-driven development, yeah.
So there's a loop where you show it to the customer and then get their feedback. But who's deciding on the quality? Is it you as a programming team, so you know it should do, or is it the customer who knows? Because I suppose as a customer, you might not know programmatically if the quality is right, but you do.
Ideally, you do that together. So as part of the BDD process, we have a meeting called Three Amigos, which is the customer, the developers and the testers. And all three of those need to gain a common understanding of what you're trying to achieve. You agree the acceptance tests, and then you go through your sprint and you review those together to see if you've actually achieved those goals. So it's quite important that you all gain that common understanding, but our customers will have the domain knowledge. They'll be kind of feeding into that process, so we'll tend to be relying on those for that information.
Yeah, following into that conversation, the problem that I encounter with that model, because that's ideally where we're trying to go, is in the business, because you work on financial years, so costs are kind of fitted into annual budget type things. Time is therefore constricted into 12-month period of time, and then scope gets kind of fixed a lot because people want to see deliverables. So while you're therefore trying to write quality code and do quality work, because it's technical work, and because the business owners can't understand the technicality of it, and I'm probably not very good at explaining it to them, that becomes a problem because there's a kind of
tension there?
There's a tension there because whilst we're trying to achieve quality, it would seem that we're reneging on something else like scope, time and cost, which then from a sort of business level point of view is a problem.
Yeah, well, I mean, these models come about from us having these discussions with our
Yeah,
customers, so it's something we're quite familiar with, and we push very hard to keep that first, and then we try to shuffle these ones around. So we, where there's a fixed deadline, where there's a seasonal deadline that we have to work to, then you have to create some elbow room in the scope. If this gets questioned at all, then it's just a false economy.
I agree.
If you don't have that conceptual integrity, then you're going to miss your deadlines because you're going to run into problems. You're going to have more unknown unknowns. But there's a skill in terms of creating elbow room here. So sometimes you need, sometimes it's easy and you have a list of high-level features and you say, right, minimum viable is there halfway through and we should be there halfway into the project schedule and these ones out there. Other times it's not as easy as that and you need all the headline features, but sometimes you can create elbow room within the features and say, okay, well we can achieve all of those, and one model that we got shown which is quite good, which is kind of like a sort of skeleton approach to your user stories, is you have a backbone across the top, which is, and then you have user stories coming down under your headline features. So you get all your headline features, and then it's a question of how many embellishments you get under each of those headline features. So there's different tactics, but ultimately, if you have those fixed deadlines, then you have to create that leeway in the scope.
Just quickly, I guess with embedded software, there's going to be maybe non-functional demands. Are they all definable and implementable via AUD?
Hopefully, yes. So wherever possible, we want to try and automate those, and the automating of those particularly helps in terms of regression testing. So you can start off in the early iterations, and you've got you're meeting your performance requirements, but as the project goes, they can deteriorate. So wherever possible, you want to automate those. And if you're not, then they need to be on a checklist in terms of your sprint releases to make sure you achieve them, actually mainly for regression reasons. Okay? Thank you very much.